So my name is Kurt Roloff. I'm the CTO and co-founder of Duality Technologies. And I've been working for the past decade with Yuri on making homomorphic encryption usable, accessible, trusted, and deployed for real-world applications. Our latest work on this is the OpenFHE library, but we have a long history of trying to make these tools usable for applications. The trouble is that there has historically been challenges associated with the usability of these capabilities and running programming operations on top of that. We're very excited to be collaborating with the OpenFHE team and the Transpiler team at Google to enable the standards compliance usage of homomorphic encryption while reducing the bar of expertise needed for actually using these tools and technologies.
Hi, my name is Yuri Polikov, and I'm head of cryptography at Duality Technologies. And I'm also a project lead and member of the cryptography team for the OpenFHE project. In the OpenFHE library, we include the state-of-the-art implementations of common fully homomorphic encryption schemes.
Hi, my name is Miguel. I am a product manager at Google, working in the privacy team. My focus is on privacy enhancing technologies. And as part of that, I work on the fully homomorphic encryption team. Part of our objective internally at Google is to make it possible for internal teams to use fully homomorphic encryption in their products. And our first venture into the FHE world was the Transpiler that we released 1 year ago. Let me take a step back. FHE is a relative new concept that was invented a few years ago. And as a new concept, it's very specialized, as in you need people who have studied potentially PhDs in the field to be able to produce programs that are able to do computations in an FHE manner. This, of course, creates a barrier of entry because you need to have this very specialized skill set to be able to do computations with FHE. The Transpiler sort of removes that barrier because it allows any developer who already writes code in C++ to be able to run that code on top of encrypted data without needing to have the knowledge of FHE. So that Transpiler sort of makes this translation between code written in C++ into code that can operate on encrypted data.
OpenFHE has been an ongoing project of our collective team for the past several years to develop a broadly usable and trusted post-quantum homomorphic encryption capability. We've always been a community effort with participation from large leading groups such as Intel, Samsung, funding from DARPA and the DoD, and usage by, for example, major defense contractors such as Raytheon and CACI. OpenFHE provides one of the few libraries that supports all of the major homomorphic encryption schemes. And we're very happy to have connected with the Google team to help provide a broader set of homomorphic encryption capabilities as represented in OpenFHE. Of course, I can't speak for the Google team, but I hope to think it makes sense for them to reach out as us as represented in OpenFHE to provide a broader set of capabilities to their Transpiler project.
In the OpenFHE team, we're constantly pushing state-of-the-art in fully homomorphic encryption. We're advancing various schemes, and for integer arithmetic, for real number arithmetic, for Boolean circuits. And the Google Transpiler project targets Boolean circuits. And in a way, we live in a world where computers are constantly used and computer architecture deals with zeros and ones. And working with those bits at the level of bits is very hard. And to build something useful, thousands and millions of bits need to be combined, and Boolean circuits have to be optimized. And this is the same problem that we have in the case of fully homomorphic encryption. OpenFHE exposes the capability of working with zeros and ones. And the Google Transpiler makes it usable, practical, so that someone can write a program in C++, and then this program will get compiled and can get some functionality that is useful in practice. Yeah, I would like to highlight that it has been a pleasure collaborating with the Google Transpiler team, and we've had very interesting conversations, discussions about the future of FHE, about expanding the capabilities. And on the one hand, we're providing the backend, OpenFHE backend. On the other hand, we're also exploring the Transpiler. So one of the members of the OpenFHE team, David Cousins, is currently using the Google Transpiler for various applications.
I think that for us, the impact is to really change what I call the data equation. At the moment, all of these applications that run over the internet run over the assumption that at some point you need to decrypt the data to be able to process it. That is, if you're asking what's going to be the weather today, the server answering that question needs to know what city you're asking the weather for and at what day and at what time and so on. And of course, you know, like that's a very vanilla query, but there are other queries that might be more sensitive. So I think what's really promising about all of these developments is that suddenly we're entering a world where the server doesn't really need to know what you're asking it. The server will just receive a bunch of encrypted data. It will not have the capacity to decrypt the data. It will then process the data and then send an answer to your device. And I think that really changes the equation of how we think about data in the server and how we take care of data at the server level. And that's just going to open a set of new capabilities in the internet, but also change the trust equation for the users.
The vision 5 years from now, what I would like to see tools such as Google Transpiler creating a layer that cannot be seen by the user, that does not affect the user experience. And when a user or developer writes a program, that program will be executed in the same way as if this program was written for to work with data in the clear. So the two major challenges of fully homomorphic encryption, in my mind, are usability and performance. And Google Transpiler is a great tool to improve the usability. Of course, we still have to work on the performance side as well through using hardware acceleration. So the hope is that we could create this layer of encrypted computing and make this layer almost invisible to the user.
Homomorphic encryption and privacy technologies writ large have been a very long-term activity in the R&D, legal, and technical communities. They've been hypothesized as a panacea. They've been hypothesized as a way of solving broad sets of problems. The challenge with homomorphic crypto is that they do provide a broad set of capabilities. And the challenge with a broad set of capabilities that work is that people always want more. We do see our engagement with homomorphic encryption and our engagement with privacy technologies through OpenFHE and the Transpiler as a very long-term type activity as we democratize access to data sharing, to capabilities, and make the world a better place for the social good of transparency and privacy, trusted privacy. Going forward, we do see an ongoing need. We've always seen privacy technologies and the capabilities of privacy technologies as a receding horizon. As we move forward and develop new capabilities, there are always new things that we need to address that are new. As Miguel mentioned, there's a broad set of capabilities around secure query type capabilities. There's a broad set of capabilities around machine learning, and that we are now making available both commercially and through the Transpiler. As we move forward with these sets of capabilities, people are going to want more, teams are going to want more to address broader sets of use cases in operations on sensitive data, whether it's medical, financial services, government operations, or so forth. We're very proud to be part of an open community around OpenFHE and the Google Transpiler. We're very proud to be continuing in our collaboration with Google and the broader community writ large, both with open source and open standards. Thank you.